3D printed top surfaces can look pretty rough and unappealing. Ironing is a slicer feature that uses the printer's nozzle to pass over the finished print again, resulting in smoother top surfaces. In this video, I'll first show you how to fine-tune the slicer settings for perfect ironing. I then tried to improve ironing and ended up designing my own custom nozzle that I got machined from copper. Let's get right into it here at JanTec Engineering. Thanks to VOXELPLA for sponsoring part of this video. Back in late 2020, Prusa added ironing to PrusaSlicer with the 2.3 release. I remember being really excited about this. In fact, I even made a tutorial on my German channel back then. The idea is simple. The hot nozzle passes over the top surface again to iron it smooth, just like ironing your clothes. This can be seen when taking a look at the G-code preview in the slicer. What I really love about this is the idea of using the 3D printer itself for the post-processing. There are a few parameters that can be tweaked for optimal results depending on your printer, material and nozzle size. I'll cover them later in the video. Ironing is especially useful for flat objects like boxes, logo plates, badges, or when you want to glue two objects together and need a flat and smooth surface. On the other hand, ironing does not work for organic shapes like figurines or angled surfaces, at least with our generic slicers. I recently did a video on an open source non-planar ironing approach that allows the printer to move in all three axes to create ultra smooth top surfaces, even with organic shapes. That's, by the way, what got me back into the ironing topic. Let's first tune the settings in our slicer. I'll be using my Prusa MK4S for this, but you can do this test on pretty much any machine. When you enable ironing in PrusaSlicer, there are two advanced parameters that can be tweaked. The first one is flow rate, which basically tells the printer how much extra filament to push out during the ironing pass. More flow can help fill tiny gaps, but if you overdo it, you'll end up with streaks and blobs on the surface. The second one is spacing between ironing passes. That's just the distance between each pass of the nozzle. Smaller spacing means more overlapping passes and a smoother surface, but it also takes longer to print. If you just leave these settings at default, you might find the result looking a bit squished or overfilled. The best way to find the sweet spot is to try a range of combinations for these two settings. At first, I added a bunch of small boxes in PrusaSlicer and assigned each one individual settings, but then I found out that there's already an ironing calibration model on printables. The link is in the video description. I downloaded it, sliced it for different spacings and printed it in VOXELPLA PLA Pro. Looking at these results side by side, my personal favorite was 35% flow rate with 0.1mm spacing. That gave me a nice, smooth finish without those over extrusion marks. But this really depends on your printer, nozzle and filament, so your numbers might be different. Once you've dialed this in, you'll have a solid baseline for perfect ironing in the future prints. You can run your own test by either downloading a pre-configured test model as 3MF or by assigning custom ironing values as you like. Click on the height range modifier, then add settings, ironing and adjust the values as you like. By the way, a quick update from my new studio renovation. I finally finished painting the first two walls and built these custom workbenches for my 3D printers. It's already making the space so much nicer to work in, and I'll have a dedicated video about the whole setup soon. Now let's see how ironing actually performs in some real-life applications and also compare the print time and dimensional accuracy of the parts. First up is this paper towel holder, printed once without ironing and once with ironing enabled. The iron surface is smoother and feels so much nicer when you run your finger or thumb over it. For this model, ironing also increased the print time quite a bit. On a 100mm by 100mm flat surface, enabling ironing adds about 1 hour and 50 minutes to the print. If you scale it up to a big project, it can get crazy. On my JanTec logo plate, ironing added almost 8 hours of extra print time, at least with the default speed settings in PrusaSlicer. I also measured the dimensional accuracy with calipers, and here are my results. Ironing adds around 0.05mm of thickness, at least when having a flow rate over 0% enabled. This is because the nozzle extrudes material, which can influence overall thickness. For most applications, this should still be accurate enough. If you're wondering what these test pieces were printed from, I made them using high-speed filaments from VOXELPLA, the sponsor of today's video. The VOXELPLA Plus HS and VOXELPTG Plus HS are engineered for utmost reliability, strength and affordability. But how do you even test the filament's reliability? Well, VOXELPLA runs their own 250 machine print farm in Southern California, and they exclusively use their own filaments for all their work. The Plus stands for enhanced toughness, offering approximately 3 times the impact strength of standard materials. The HS stands for high speed, making these filaments perfect for modern machines from Bambulab, Prusa and Crealit, ensuring you get that high quality without sacrificing speed. And they managed to do this at a fantastic price point of just $16.99 per roll, with additional bulk discounts available. In addition to their filaments, they also offer innovative 3D printer upgrades. For example, check out their X filter and Bento Box 2 stage filter solution for Bambulab printers. It's a very clever system designed to remove harmful nanoparticles and odors for safer, quicker and higher quality prints. So if you're looking for reliable yet affordable filaments or some genuinely useful upgrades for your setup, I highly recommend checking them out. Use the link in the description and you'll get free shipping in the USA when you purchase $75 or more. Thanks again to VOXELPLA for their support. When working with ironing, I noticed a couple of things that could be improved. First of all, it's really slow. As we've seen earlier, ironing can easily add hours of extra print time, especially on larger flat surfaces. Then there's the problem of the nozzle itself. A regular 3D printer nozzle with its opening in the center can leave a texture on the surface. Another thing I noticed is that material can stick to the outside of the nozzle during ironing. Because the nozzle is still extruding filament, small amounts can collect on the flat face. Eventually, that bit of material gets dragged across the surface, leaving visible marks. So while using the same nozzle for printing and ironing is practical, it's not really optimal for getting best possible surface quality. That got me thinking, what if we had a nozzle designed specifically for ironing? With tool changers like the Prusa XL becoming more and more popular and accessible, I thought, why not make a dedicated tool just for ironing? I love the idea of using the printer itself for post-processing, and tool changers have so much more potential beyond just printing in different colors and materials. They could be used for applying release agents, inserting hardware mid-print, even taking measurements while the print is still running. The list goes on and on. So why not dedicate one of my 5 tool slots on the XL to ironing? Here's the idea. Instead of a regular nozzle with a hole in the middle, I designed one with a completely flat tip. That way it wouldn't leave those circular marks and there's no opening for material to ooze out and stick. The large flat surface with a diameter of 5 mm would simply glide over the print, smoothing it out like an actual iron. With such larger surface, ironing could be done within a fraction of the time it usually takes. But then came the question, how do you actually make one of these? In theory, I could have started with something as simple as an M6 screw, machine it flat and call it a day. But I wanted something more precise. So I went all in and had my design turned at PCBWay's online manufacturing service from copper. I honestly wasn't sure they'd be able to manufacture it, but they nailed it. The finish is beautiful, the dimensions are spot on and the M6 thread fits perfectly. Now let's get to testing the nozzle, and oh boy, this turned out to be a pain. At first, I installed the copper nozzle in the 5th tool of my Prusa XL using a V6 twin extruder adapter. Next step was figuring out how to get the printer to actually use this tool just for the ironing passes. That's where things got tricky. PrusaSlicer doesn't allow tool changes within a layer. In the slicing preview, there are 2 sliders. The vertical one shows how the layers are stacked. And before each layer you can change tools, switch filaments or add custom G-code. I've used that feature a lot in the past, adding hundreds of lines of custom code here. The horizontal slider, on the other hand, shows the nozzle movements within the current layer, and that's where the ironing happens. Unfortunately, you can't insert a tool change here directly. My first idea was to do it manually. I opened the G-code in my text editor, found a section where the ironing starts, and tried inserting a tool change command. But Prusa XL's tool system and start G-code macros made this more complicated than I expected. I started analyzing various G-codes with actual tool changes and noticed that I needed to declare the tools in the top section. I made many test prints, but always ended up with the firmware crashing or an error like this one. The second idea was to split the print into two STLs in PrusaSlicer, one containing everything except the top ironing layer and one with just that last layer with the ironing pass. The plan was to assign the copper nozzle to the second STL. In theory, it's a neat workaround. In practice, it still didn't produce the results I wanted. I still wanted to prove my concept, so I heated the nozzle up to 200 degrees C, put on my safety equipment, and tried ironing manually. I think it shows that the approach could work with tune settings for height, speed, acceleration and temperature. So was it worth all the hassle? From a practical standpoint, no. But that's just how experimenting works. You're not always successful and that's fine. The only way to come up with something new is to try things, break things and see what happens. I'd love to hear your thoughts on this. Do you know a trick or workflow that could make this dedicated ironing nozzle work on the Prusa XL? Let me know in the comments. Maybe together we can solve my problems and have one of the first add-on tool for the Prusa XL. While I don't think top surface quality is the biggest challenge in 3D printing, to me it has kind of a bigger meaning. It's about the idea of using the 3D printer itself to handle post-processing automatically, maybe even in ways it wasn't originally designed for. That concept has so much potential, and ironing is just one example of what could be possible. In my opinion, we need more open slices that make it easier for users to create their own plugins and push the boundaries of what our machines can do. Thanks for watching, I hope you enjoyed this video. Also, a huge shout out to my channel members. And just a quick reminder, when this channel reaches 25,000 subscribers, I'll be giving away a Prusa CORE One kit using the Prusameters I've collected. So if you're not subscribed yet, now's the perfect time to do it, so you don't miss out. Thanks again, and I'll see you in the next one.